I've been messing about with various bits of technology of late. And there was the block detectors. I added block detectors for all the upper decks so that the JMRI knows where which blocks are occupied and roughly where trains are. There was the RFID stuff, which tells JMRI which train is in those blocks and allows it to track them. And then also I've been tweaking a bit of software I wrote a while ago that's intended to act as a kind of cab signalling system and warn me of any impending dangers that may be about to befall any trains. And once all that was done, I thought that it was a good time, since there was kind of new stuff flying around, it was a good time to look at maybe redesigning the Knobbox. So I went down and spent a day with my friend Simon, and we put our heads together and we've come up with this. So I went down to Simon's workshop armed with a screen and a few knobs, and plonked it all on a table, and he came up with this design and got it all laser cut and everything within a few hours. And I mean, it's a massive step up from the old one. It's still a prototype, still needs a bit of tweaking, but it's definitely heading in a really interesting direction. Another big change on it is the screen. The old one had this old screen thing that was only really capable of text, whereas this has got I think it's something like 420 by 480 by 320 maybe, LCD TFT screen in it, still connected to the ESP32 inside, and it's kind of nominally split into 6 squares. So there are 6 throttles on it, and each of the squares next to each throttle represents what's happening with that throttle. So there's the name of the train, there's the speed, direction, and the little meter that goes around that just kind of makes it look pretty, the code for which I nicked off the internet. But also a step forward with this is it also integrates cab signals. So each meter for each throttle also displays the current signal aspect that each train is under. It might be worth taking a little time, hopefully, to try and explain why I'm doing this. And I think what it comes down to is I'm trying to introduce some unpredictability and randomness to what is ultimately just driving a few trains around in a few ovals in a loft. And the way I can see to introduce that unpredictability is to mix ideally manual trains, but possibly semi-automated trains, with automated trains. So you've got that relative unpredictability of, if I've got a few manual trains going around and a automated train starts to a schedule, then the manual trains could be anywhere, and that's quite random. And when that automated trains start, that automated train may well cross the lines that my manual trains are running on, and I may have to take remedial action, such as go down to caution or danger and stop. So I think all of this, the block detection, RFID, the RFID has certainly helped the cab signal thing. The whole point of all this, I think, is to create this environment where, to an extent, I've got to concentrate, because unpredictable things may happen. So once I realised I was kind of going down this route of possibly being able to display cab signal information on the controller itself, and which, you know, tell me when trains need to slow down to caution and stop, I started looking for alternative screens, because the screen that's on that current Knobbox is a bit limited. It can only really display text, and I wanted some way of being able to display signals for each throttle as well. The first thing I looked at were these little 0.9 inch screens. Now these are I2C serial, and I made a bit of an assumption here, because those boards that control the servos, they're I2C serial as well, and they can all be chained together. So I assumed I would be able to chain a bunch of these together, because there's always a limitation, because the knobs on the Knobbox take 3 pins each. There's always a limit on pins on the ESP32 that's controlling it. I can't just go for lots and lots of pins. So the advantage of these, I thought, was because they're I2C serial, if I connect one, I can connect six, and it won't take as many. It won't take any more pins up. But actually, that's not true. Unfortunately, these things, they're not individually addressable like the I can't remember the name of those boards now, but the ones that control the servos, you can change. I mean, there's one just there, whatever they're called, I can't remember, but they've got these solder pads on them along here, and these allow you to address them and chain lots together, and lots of different addresses. You can have goodness knows how many chained together. These ones don't have those solder pads, and they have. I think you can possibly have two on two different addresses, but that's the limit. So I kind of veered away from those a bit. Another option which I really liked, actually, which I was about to go with, was these addressable LEDs. They're multicolored, and from one pin effectively on the board you can control every single pin, every single LED in this chain, give them different colors, turn them on, off, do all that kind of thing, just from one pin, which I think is incredible. And because they had those solder pads between each LED, it would be a case of, say, with the 3x3 knob box, just cut three off, connect them all up, and then have three cables running from the solder pads there, put another three on the other side and connect them up underneath. So I did really fancy that. But then I discovered these, and these are the screens that I went with in the end. This is an SPI serial screen, LCD TFT 4-inch, and it's, I think, 480 by 320 pixels, and it connects to the ESP via SPI serial. And I decided, because it's then just a single screen to manage, but it's big enough to split into those 6 sections for 6 throttles, this seemed the best approach to go for, in a way that I could represent everything on the throttle as well as the signal aspect in just one screen. I'm just going to go through a little bit of detail on how I got started with this screen. First of all, this is the screen I bought, and I'll add a link to it in the video description. They're not massively expensive. I think actually this is the non-touchscreen version, but it's only a couple of pounds more for the touchscreen version. I then found this library, which was incredibly useful and got me started. There are some good examples in there, again, of meters and the things that I was particularly interested in displaying on the screen. This video I'll create, and I'll add a link to it as well, got me started with all of the connections, where to connect it on the ESP, but also some information. This library is quite unique on how it's configured and how the pins are configured, particularly with respect to a setup file that lists the type of display you're using and also which pins you're using. This video I learned from goes through extremely well. There's no point in me remaking it. This is a good example of the first meters that I saw in that video, and what got me started. However, there wasn't, as it happens in that library, the perfect meter for me. So I did a bit more Googling, and I came up with this, which is the library that I've used. I'll include a link to this as well. Actually, I think there's a link in the code as well. And these are the meters that I thought, yeah, they're going to work best for my purposes. And I think actually by by coincidence, the person who wrote this article is the same person who wrote this library. It's possibly also worth noting at this point that I have given the pins of the screen here custom values to me rather than the default ones that this file contains. And the reason why I've done that is using those ESP32 modules. As I've mentioned already, I'm always very short of pins. Every pin gets used, and there are some pins that have a kind of conditional use, like 0 for example, whereby if there's an input device attached to that pin, and if that input device is currently set to high, which is very possible with all 3 connections actually on the knobs, then in some cases the ESP won't boot, and in other cases it won't flash. So what I've done is I've set most of the very sensitive pins, the conditional use pins, to use on the TFT, because they'll be set as outputs, and that will free up as many of the kind of standard universal use pins as possible as inputs. Once I'd got all that connected and working, it was surprisingly easy to get to the point where I had those 6 meters on the screen. I updated the controller class so that when the controller is created, this is its index on the Wii throttle app. These are the pins that the 3 pins that the knob is connected to, and then these last 2 numbers on the end here are the X and Y coordinates of where this throttle's little square starts on the screen. So the first one's on 0, 0. Second one has an X value of 160, so it's halfway across the 320 narrow screen because we're in portrait mode, and obviously it's 0 because it's still on the top row, and then they just increase in value as they go along, and that gives the X and Y coordinates of each of the little 6 subscreens. And really it's not then that much more complicated here. Once I'd copied the ring meter function in and done very little to change it, really, it's one line will draw that meter and draw it with the value set. Here's the value. It's just getting the knob position from the throttle. It will draw the meter, use its X and Y coordinates, add a little bit to it, and then just display it with the value that the throttle is currently at. And so on to the signals then, and how they're working, and how the software that's running is able to communicate to the Knobbox which signal each of the trains it's controlling needs to be acting upon. And to demonstrate that, I'm going to get the class 43 up and running. This screen looks quite a lot better in the actual real world. It gets very reflective on the screen. I've made a small change as well, actually, if I let that go. These screens, I don't know much about LCD screens, that kind of thing, but when they had those 6 meters on them all the time, regardless of whether they were being used, would mean they were on the screen all the time, and I just got a little bit concerned about whether that would cause burn-in, which probably doesn't matter because they're the only things that are ever on the screen anyway. But in the end, I thought it might be a good idea just to have the screen completely blank, so when it's not running a throttle, there's nothing on there. I'm going to go find that class 43. There it is. That's the one. I think is track power on. Yep. So this should get the 43 up and running. And at the minute, there's no, if I just focus on that, there's no signal. There's the train just going past. That kind of green circle, empty circle, means that at the minute there is no cab signal has been assigned to this train. And as that class 43 starts making its way around the layout, there is an RFID reader on every loop. And this one has just crossed the RFID reader for this loop, actually. It's just after that set of points. So once that happens and everything syncs up, the JMRI now knows as blocks go active, it knows which train made that block go active, and that information is also added in the API, so that once we get to this software that's tracking these journeys and tracking blocks as they go active and working out where the train that made them active is going, and also any dangers that are ahead of it, 1 block ahead, it's also picking up from the API the ID of the train, because that's in the block information. So now this software not only knows that it's tracking a train and that it's looking 2 blocks ahead for any dangers for that train, but it also knows which train it's doing that for. And then coming back to the Knobbox and carefully using the reflection of the phone to make it a bit more visible. Of course, this is where everything links up again, because the Knobbox, by controlling this train through Wii throttle, also knows that it's controlling train with ID 28, which is the class 43. And once that's all linked up, that's that circle that was once kind of an empty green is now a full green, which tells me that the signals for this train are now being tracked. and should for whatever reason those signals change to caution or danger, that will be reflected on this screen. Let's have a go at doing exactly that then. When this 43 comes round and passes the turnout that's right in the middle of the screen there, I'm going to set that turnout against the 43, which should of course trigger the software up there to make those audible noises and warnings. I can see that's tracked there. Now it's crossed there, but what it should also do over here is set this signal aspect on the controller to match the current level of danger. I'm going to get a hand ready as well so that I can actually slow the thing down. There we go. So immediately we went to caution and we've got a little caution, and now we're in red as well. So I'm going to stop that train. And coming up here, here's all the noisy mess that it's making because it's not happy about the state of the layout. But if I come and just set this back so that it's in favour of the train that's going to cross it, we've got a green light back, or a green bar kind of saying everything's all right there. And coming back down here, the signal has gone from red back to green again, and I can set the train back off on its way. That's kind of what it does then. So I'm going to try and describe briefly again how it does it. And really there's just 4 letters that describe how it does it, and that's MQTT. It's been, there are lots of advantages for me to use an MQTT around stability and reliability, but the other one is MQTT is not specific to JMRI. JMRI is a client of MQTT, just like everything else is, the Arduinos, the Knobbox, ESPs, whatever. So it's not a protocol that has to go through JMRI, so it can be used for messages to be sent between different accessories that are around the layout, and that's what's happening here. So the general approach to it really is when I'm going through and I'm selecting here which loco I want to use, it's showing me the DCC ID of that loco, and it's got that through throttle, and that's what it uses to control the train. So say if I go with class 37, now as soon as I've done that, what the ESP underneath on the background is doing, because it's connected to the network through Wi-Fi, is it's subscribing to a MQTT topic of something along the lines of layout / cab signal / 37, just the same way as when I set that class 43 one up. I think that one's ID is 28, so it's subscribed to cab signal or layout / cab signal / 28. And then whenever it gets a message on that topic, it knows that's a new aspect for the signal. And this app is simply, whenever it detects a new block and it does the detection for whether there's any danger in it, because it knows when it gets that new block, JMRI excuse me, because, you know, demonstrated here, JMRI knows what train's in the block because of all of the RFID reading, and it's putting that in the API that this thing's reading it. When a new block goes active, when it checks that block, it knows the ID of the train that's in that block. So when it's done its processing and it's decided what the aspect of signal for that block should be, as well as displaying it on the screen and making all those horrible noises, it publishes to MQTT what the state of that signal should be. And here are the ones, this was subscribed while I was doing that demo previously, and that's where all of the statuses were set. And if I just stretch over and set this 43 going again, sorry about that, I think I've been too close to the screen. So as the 43 goes through new blocks, we should see this increase one line for each block it goes through. There's one. If I come back out, I might be able to kind of show the state of the layout as well. But this kind of in a nutshell is what the combination of the software, the Knobbox and MQTT are doing. The 28's about to come around there. I think that went active then. So every time a new block goes active, check
what train is in that block through the RFID stuff that JMRI gives us, then check ahead of the train for 2 blocks to make sure that, or to determine if there's any danger, and then send this MQTT message out with the results of those checks. And it's that MQTT publish that this ESP down here is simply subscribed to, and it's just a simple process of, if you get caution, make the circle red. If you get if you get caution, make the circle orange. If you get danger, make the circle red. And if you get proceed, make the circle green. So where do I go with this? Well, first of all, it's helpful for me. It's helpful for me to stop making mistakes when I'm just running trains manually. And when I just had that app going, what I was tending to find was it was making noise, and it was kind of stressing me out because it was making noise. But it was just telling me which block the issue was in, and which block the train was currently in, and then I had to go to the old Knobbox over there and I had to work out which train it was and blah blah blah, and by the time I'd done all that, I'd probably got the short circuit or the collision anyway. So the advantage of having the cab signals on the box is that as soon as I hear the noise, I go and look through the active throttles and I look for the one that's caution and I look for the one that's red, and it just saves me a good few seconds of brain processing time. But as I mentioned earlier, the other avenue that I want to explore with this is interacting with automation. So if we just take what's actually kind of accepted and available through JMRI automation, and that's running semi-automated trains with automated trains, the process of having lots of kind of scheduled trains, most of which JMRI runs itself, but the occasional one, it treats as an automated train. It sets all of the signals and the turnouts and everything for it, but it expects me to drive it, which sort of makes it a little bit more interesting, because what that box then gives me is, as that semi-automated train that I'm driving interacts with all the automated trains on the layout and has to slow down and stop because they may be crossing paths, I've got a mechanism to know when that train needs to slow down and stop, outside of having to follow the thing round with my eyes, look at the physical signals on the layout, which, for the way I'd like to use JMRI, is a real bonus.